Hi, Victoria.
Hi, Shani.
Can you hear me?
Yes, I
All
can
right.
hear you. Can you hear me?
Is my voice all right?
Yes.
Okay,
Can you
okay.
hear me
All right,
clearly?
good, good. Okay, yes. Okay. All right. And
Oh, okay.
my earphone, I think it was dropped this earlier this but
Oh,
okay.
okay.
All
Okay.
right. So I think we can is Professor Herman coming or
I think he said he wouldn't be able to join this morning.
okay, right.
He
All
had
right. So let's
something.
start then.
Yeah.
All right, okay. All right.
Okay.
So how have you been? How was your
Uh,
weekend?
it was quite restful. Maybe I
Oh,
rested
okay.
a bit too much, but it's all good.
Okay. Okay. Nice.
um,
You survived.
yeah. Okay. So I was trying to. Let me just share my screen.
Okay, sure. Go ahead.
Can you see my screen?
Yes, I can see it. Okay.
Okay. Apologies that I wasn't able to do too much. I tried
Mm-hmm.
so hard, but nothing much. But I think what I just tried to do, I tried to clean up, the the process, the matching sequence, as well as
Mm-hmm.
getting the precise, parameters, the message parameters. For example, what's the ID, and
Mm-hmm.
basically this is supposed to be a 128 bit or
Okay.
16 bytes. I tried to add the bytes
Right.
as to the size of each message.
Mm-hmm.
This one we can leave that for now. But the idea was the subscription list is about that size for Python.
Mm-hmm.
I'm guessing it's the same for
Okay.
all programming languages.
Mm-hmm. Okay.
Match distance is just one unique integer, which is what 28
Mm-hmm.
bytes. And the idea was to now sort of just create the exact what happens, for example, when we generate, dictionary, for example. So
Mm-hmm.
here,
Okay.
this is actually supposed to go there. But you have the MID, the matcher position, or in this case, I changed it to matcher coverage because I think that's more of a better way to say it, call coverage area or something like that.
Mm-hmm.
CVA,
Okay.
we use that. So you have an idea of the neighboring matches. You have
Mm-hmm.
the IDs, you have the position, and then you have the distance. I think that's
Mm-hmm.
the major thing that changed from the last time, which is how far the neighbors are to you, and
Mm-hmm.
in terms of the direction.
Mm-hmm.
So, for example, if it's on the x-axis, the negative x-axis, then
Mm-hmm.
it says it's on this position, covering this area, and we sort
Mm-hmm.
of know how that is. Wait a minute. Now I'm thinking about it. Should I have both coverage and position?
Mm-hmm. Okay. So
That sounds
so
better.
what is coverage though?
So coverage is the area in within the
I
matcher.
see. Okay. So hold on a sec. Right now you are describing the data structure, right? Or the message
Yes,
format.
yes,
For
yes.
what? For what?
For the matches.
For matchers to exchange information.
Information, yes.
Oh, I see.
So yeah.
Okay.
Yeah.
Okay. I see. Okay. So, but why do you think the matchers need to exchange this information?
For starters, for example, when you want to forward information, you want to know the quickest route, right, or the
Okay.
fastest route to go. For example, and
Okay.
that's what I was talking about last week in terms of if the matcher is on the left, you don't want to start moving on the right by default now. Of course, in practice,
Okay.
it's probably not going to be that simple.
Okay.
But
All
in
right.
theory, on an XY plane, if the matcher is located on the left side of the axis,
Right.
um, you probably want to check the nodes on the left side first, because that's
Okay.
probably the fastest
I
in
see.
theory.
Okay. All right. Okay. Let me just sort of okay. I guess put some things into context. Okay.
Okay.
which is, I think there are some assumptions we can make first. Okay, about basically, for example, okay, I see. Okay, I see. Okay. Okay, I see you are sending the coverage, which is the size, right? I'm sorry, the
Yeah.
area, right? The
The
area that
area coverage.
matcher is,
Yes.
the matcher is basically controlling or managing.
Yes.
Okay.
Yes.
Okay. All right. So I think okay, I see. Let me put it this way. Okay.
Okay.
Okay. So regardless of the partitioning,
Yeah.
okay, whether it's Voronoi or other kind of partitioning, each matcher should probably have to have a way to know who the neighbors are.
Okay.
Okay. Okay. And this is probably, I think what you're doing now is different from that, right? From that mechanism, correct? Or are you
Okay.
devising that mechanism to do exactly this?
Like I should bring it up now. I'm thinking about it. In theory, the partitioning should do that.
Right.
Partitioning should have the information.
Yeah. So this is what I guess the first assumption I think we can bring as a context, which is we can probably safely assume that each matcher has a mechanism, okay, to know about who the neighboring matchers are.
Okay.
Okay, independent from any kind of pub/sub kind of concept, right?
Okay.
Do we agree on that?
Yes.
Okay. And I think this is important, right? Because we want, okay, potentially, right? Or even ideally, we maybe we want to design our pub/sub matchup system or mechanism to be independent of the underlying partitioning, right?
Yeah.
Do you see that?
Yeah.
Okay. And so I think meaning that however we want to partition the underlying space, as long as they can provide some similar information, such as there is a function you can always query about who your neighbors are.
Okay.
Right.
Okay.
And also maybe to know from that determine what the positions and more importantly what the region areas are for each matcher, right?
Yeah.
I think that is something we can assume that there is a subsystem that provides that and that does exactly just that.
Okay.
Is that okay?
Okay. Yeah. So so basically in terms of getting the location, so that sort of comes in the process steps and not necessarily
right. Exactly.
Okay.
Right.
Okay.
Because I mean, like I'll just share with you Voronoi. Okay, like with Voronoi, the information you only need to exchange are just the positions of your neighboring matchers. Okay, because the region size you can compute by yourself actually. You see?
Okay.
Once you have the dots, right, you have the positions of yourself and your neighbors, you can throw them into a Voronoi generator, you see, to generate the Voronoi edges. Okay, and then you can determine the area overlap and all that. In fact, that is what the the Voronoi library in the VAST implementation does. You just throwing a bunch of positions, a bunch of dots. And then you can do queries such as give me a list of my enclosing neighbors. Okay. Or check if this area overlaps with a particular neighbor's region.
Okay.
You see, but that is being taken care of by that subsystem.
The Von layer, the Von.
Exactly by the Voronoi component subcomponent. You see.
Nice.
Okay. And if you have something like a hexagon, square, rectangle, I think it should be managed by that underlying, again, the subsystem or the submodule.
Okay.
Okay. And this way you will keep, first thing, whatever you actually need to do a lot cleaner. You see, right?
Okay.
And you need to do less work actually.
Okay. Yeah, it looks like I'm
You
just
see?
using what exists.
Right, exactly. I mean, you can safely assume those functions exist. Okay.
Okay.
Because that's exactly like Vong, for example. You should provide that, right? Or even if it's an alternative way to partition. And the second concept, I think it's important to keep in mind, is that don't send anything that you can compute yourself.
Okay.
Okay. For example, like I think you are sending the region area, right? The coverage, right?
Yeah.
You're trying to send over the coverage. But like from my perspective, coverage is always something that can actually be computed locally. You see?
Okay.
Because once you know the location, the positions of yourself and your neighbors, and then you also know partitioning method, right?
Yes.
You see?
Yes.
And you know whether it's Voronoi, whether it's hexagonal, or it can be even simpler for hexagonal or rectangular because it's so regular. You can locally calculate what those areas are and should be. You see?
Makes sense.
So that is another general rule, I think, when designing network protocol or message types, is that try to minimize to the minimum amount of information necessary. Okay. So the general rule of thumb is if it can be computed, then don't send.
Okay.
Okay. It not only saves bandwidth, but also will make your protocol design
like
simpler.
Computing,
right?
This is the computing necessary.
Okay.
Okay. Yeah.
All right. So do you think you have some ideas now about how this can potentially be simplified? And for example, like metric distance, that is definitely computable. You see?
Okay.
It's not something you need to send over the network.
So that can be computed on because once you have the location, it's easy to compute. Yeah.
Right. It's computable.
Okay.
All right. Okay. So I guess this is just a length of how you look at things,
Okay.
Okay.
So the idea is now over the network, you want to send as minimal a message as possible.
Exactly.
Or
right.
A request.
Right.
Okay.
Right. Okay. All right. So I guess any other updates?
I think that's mostly it. I was trying to sort of clean that up, but I think I have some.
Okay. That's fine. All right.
All right.
So okay. So I guess any other updates from like the implementation side of things?
So that I need to sit down with tonight. We have like a session scheduled with Anisio today. Just to try to clean up in terms of the message type and that kind of stuff.
Okay.
I actually wanted to clean this up first before I went to him.
Okay. Sure. All right. Yeah. But don't worry though. I mean, even if you only have a draft, it's still discussable. And in fact, it might bring clarity. Obviously, if you can, make it concise and clear, that's best. But even if it's just a draft, with discussions, you will also gain clarity on that. Okay. All right. So I think, I guess maybe what's useful now is to discuss a bit about, this is written down, you're trying to write down the procedures, the pseudocode, the sequence. But can we like conceptually like explain how this should work first, right? Just imagine you are standing at your poster board, right? And at the doctoral symposium, I don't know, they might give you guys poster boards.
It's possible. Highly likely, actually.
And people will come around, students, professors, and they will like ask, like, what is your work? Can you explain to me? Yeah. And you need to write. And I think you don't show them the pseudocode. I mean, although you probably will show some diagram, right? And try to explain things from high level, right? High level. So I guess right now, the thing for you to produce is how do you support basically spatial PubSub, right? At a sort of a protocol level.
Yeah.
Right. Okay. Given some of the assumptions we already have, right, and mechanisms that's already in place, like we assume some kind of partitioning mechanism exists, right?
Yeah.
And right, we assume that matcher locally it can perform like PubSub matching, right?
Yeah.
Right. And now we're trying to explain and design how we can like scale this to multiple matchers. So can you explain like quickly to me, like how do you scale that up? What is the mechanism?
Just the scaling part.
Right. I mean, like very simply, the question is, how do you make it from one matcher to multiple matchers?
Multiple matchers.
Right. How do you? I mean, I understand, right? You explained to me. I understand. Yeah, with a single matcher, it's very easy, right? To either do channel or spatial PubSub. That's understandable. Okay.
Yeah.
And now you're telling me that you like to scale this up to accommodate more nodes, right?
Yeah.
Larger areas, higher densities, and all that. And you need to have multiple matchers. So how do you do that?
Yes. So to enable scalability,
right,
or to allow for scalability in this case, the idea is we want to have a form of distribution across this area, and the best form of distribution, both from a research or practical based scenario, is a decentralized distribution, where the idea is you have an area locally managed by a super peer or a super matcher, for example. Right. And the idea is the peers don't know anything about one another. All the peers in this large area are not just managed by one big super peer, but managed by one local peer. And the idea is these local peers have knowledge of the neighbors only, but they don't have knowledge of all the matches in the system.
Okay.
So in a decentralized context, the idea is the super peer or the super matcher does not manage more than it can handle.
Okay.
And anytime there's an overload, the load, or should I say the computing, the processing is shared across nodes, in the area, in the local area. So for example, if I'm a super peer and I'm experiencing too much of volume or traffic, I simply just share that traffic with my local neighbors. That, oh guys, help me out. And these local neighbors, I'm trying to see how the local neighbors goes into. Yeah, that's the local scalability part. And in terms of if I want to request from someone in a longer distance, there's a routing mechanism to make that a reality. Now, in terms of speed, there might be a bit of a compromise because the larger the space, the longer it may or may not take. We don't know that for a fact.
Okay, the forwarding, right? The forwarding will take longer.
Forwarding, might take a bit of time, but at the same time, one of the things we get from that is security.
Right.
Get a much stronger security in terms of, when you hack one system, you don't hack the whole system.
Okay,
So
all right.
anytime there's a breach, it's just
So, all right. So I have good. Okay. So I have some questions. The
okay.
first one is how do you how do these matchers, okay, when you're sharing load, right? How do they communicate
How do they
to,
communicate?
right? Oh, okay. Let me simplify the question a bit. Let's
Okay.
assume that that's called load balancing. We don't
Yeah,
we don't we don't we don't talk about load balancing for now. Okay,
okay.
let's
Okay.
assume it's already partitioned statically. Okay, and you have one matcher managing a region, right, already. So tell me, how does it work? That how does spatial PubSub work in this kind of a multi-matcher architecture or layout? Yeah,
Okay.
how does it work? Like,
So,
yeah.
so I'm gonna try to use analysis with maybe X node, which is the I have is a subscriber, and
Okay.
I want to subscribe, to an area in
And if you have a diagram, that's even better. Do you have
that's
a
oh yeah.
do you
Yeah,
have a
let me
relevant
see if
diagram
I
you can
can
show?
try to see if I can find it nice. So say I am node 7, I'm going to use
Right.
this node, right?
Mm-hmm.
And I want to subscribe to an area here, maybe
Okay.
area in this matchup, with this purple
Okay.
matchup on the right. And the question is, first you understand that you want to first check this current matcha region I'm in, that okay, I'm going to
Mm-hmm.
send a request to my local super pair that,
Mm-hmm. Right.
hey boss, do you have the message I need, or do you have the area I'm trying to subscribe to? This
Mm-hmm.
matcha is going to say, oh, there's this request, I don't have it, so
Mm-hmm.
I want
Right.
to forward it to this
Mm-hmm.
matcha on the
Okay.
right.
Okay.
But remember, I don't know about this matcher in theory, and from the
Mm-hmm.
partitioning stuff.
Right. Right.
Only
Mm-hmm.
the one in the middle
Right.
knows
I only
about
know my
the
neighbor,
match.
right?
I only know my neighbor, so I have to forward it to my closest neighbor.
Okay.
Well, in this partitioning, there is this layer that performs the shortest path algorithm routine, or this greedy forwarding,
Mm-hmm.
that tries to find the shortest path to this matcher. So it
Mm-hmm.
goes to the first one. This
Mm-hmm.
matcher checks its area as well. Like, do I have the information you need? If
Mm-hmm.
it's a no, then forward it to my neighboring matcher. And now this
Okay.
matcher is like, oh, I have what you need.
Mm-hmm.
So I simply just forward the message directly back to this matcher,
Mm-hmm. Okay. Okay.
because in the request it already contains the IP and the port
Mm-hmm.
and the ID, and we simply establish like a standard, UDP connection
Mm-hmm.
to this matcher to say, okay, I received your request. I have your subscription request, and I'm
Mm-hmm.
going to save you to my subscription list. So
Okay.
anytime there's a publishing request in this area, I am
Mm-hmm.
going to forward that request both to my local nodes or my local peers,
Mm-hmm.
as well as
Subscribers,
to
right? Local subscribers.
sorry, my local subscribers,
Mm-hmm.
and as well as to you. I'm going to add you to that list of subscribers as well.
Okay, because I do have a list of subscribers,
I
right?
already have a list of subscribers, yes.
Mm-hmm.
So I'm going to add you to my sub list of my main
Mm-hmm.
list and say, okay,
Okay.
these are the network connections I have to make to
Okay.
the external
Nice.
parties.
Nice.
And
Okay.
basically adds that to that list. So anytime there's a publish request, or a publish request on this matcher,
Mm-hmm.
it's going to forward to this matcher,
Mm-hmm. Okay.
which will then handle the results. So there's probably going to be some sort of queue in here that
Mm-hmm. Right.
handles the message received
Mm-hmm.
and basically sends the message to the relevant
Mm-hmm.
publisher,
Right. The peer, right?
which
The
is this,
subscriber.
which is node 7.
Mm-hmm.
So it doesn't go back through the neighboring route. It
Mm-hmm.
just establishes an automatic connection
Okay. Okay.
to
Yeah.
this match.
Okay. All right.
So
Good.
someone is probably going to ask in terms of, but how does that not compromise on security in terms of, now this has knowledge of this, but you have to understand that this only has the knowledge of this if there's a request.
Right. That's right.
It's not like it just keeps it for no reason.
Right.
It's only when there's a request to subscribe that it keeps it. And the moment it says unsubscribe me, then it sort of loses.
Right.
There should be some.
And we can also make the assumptions that all the matchers are trustworthy among themselves.
Yes.
Okay.
Yes.
I mean, that's also important to state. For example, there could be some provision resources, right, by a company over, it could be some in different clouds.
Okay.
I mean, it's possible, right? I mean,
yeah.
Let's say you have this company that's providing spatial PubSub service, and you are renting different cloud servers, right, around the globe.
Yeah.
Right. So basically, you can assume that the matchers among themselves are trustworthy.
Among themselves, yes, precisely.
Yeah, among the keyword is among themselves, right? They form a trusted network, right?
Okay.
So all right, I mean that's just a quick, but that's kind of a digression. Okay, it's the core. All right, so I guess you explain how I can subscribe to area outside of maybe my current matchers area. Then can I publish to area that's outside of my current matchers?
Yes. I mean,
okay, and how does it work?
It should be possible. So this is it. This is who I am. I'm going to use Node 7 again as an example. I am Node 7, and I want to publish to an area that my matcher does not have. Right. So it's a case of, okay, I'm going to tell my matcher this is who I am, and this is where I want to publish to.
Right.
Right. And the matcher checks like, whoa, I don't have what you're looking for. I don't have I don't have the area. I'm not within the area you're requesting. So I'm going to find the nearest matcher that has that area that you're looking to publish to. So it performs internally, there's the greedy forwarding again that happens where I'm trying to find the shortest path to the matcher area that contains that publish request area.
Okay.
So I forward to matcher X or this one in between. This one checks its area. It's like, no, I don't have it. Then it forwards to the next one, and then this one checks and like, oh, okay, I have what you're looking for.
Okay.
You're a publisher. You want to publish here? Cool, no problem. So whatever the message is, I simply just decode the message here and I publish it.
Okay.
So it's like
send it to the subscriber.
So
right?
yes. So this makes the publish request. The matcher handles the message from the publish request and it's simply just forwarding.
Right.
And this is the matcher here also like decodes the publish request. And then looks through. If it sees that it's a public request in its area, it scans through its subscriber list, and then it checks, oh, who wants this or who is subscribed to this area. If it finds that there's people subscribed to this area and the subscription list, it simply just disseminates the message. Now that I think about it, there should probably be a standard for decoding messages.
Okay.
Or requests. Like anytime there's a publish request, there should be like a standard process.
Yes.
There already is, but it's not like in the code. It's just
okay.
Like, but it's fine.
Okay. All right. I think that works. Okay. So Victory, you know? I mean, was it easy for you to just explain this way?
Yeah. It's
explainable, right?
Yeah. I think maybe 8 months ago, I would have been rambling on and.
Okay. Good. So basically, your task now is just to write this down.
Yes, absolutely.
Okay. I mean, write it as steps and then make sure that each step, if it involves a communication, right?
Okay.
Then what should be the information about? What should the packets be?
Okay.
And then how should they talk to each other? Like in what sequence? And that's the protocol. Okay. So that's it. Okay. So, I mean, you see, translating into message format and protocol isn't that, that big a problem. I mean, a hassle. It's just what you were telling me, and just, try to capture that in words, documents, steps, and also check if each step can be supported by a, message that's being exchanged, and, a protocol, which is kind of a language, right? Like, this is a command with these content in the packet.
Okay. It makes sense. It makes sense.
Okay. So yeah, so I think for tomorrow, if you can, create this basically this message protocol and format for just the publish and subscribe procedure. Okay.
Okay.
I think that would be good. Okay, that would be great. Okay.
Okay. I'll do that.
Right, and I mean, probably revising what you have already written, because I think that can be simplified a lot more.
All right.
Okay.
Makes sense. Makes sense. Yeah.
Right.
Yeah, you're not wrong. Yeah, you're not wrong.
Yeah, you have to be aware of what assumptions you can make. Okay, and those assumptions, they not only help you to simplify things, but also make the mechanism more general. You see. Okay, because you want to separate spatial partitioning, the actual mechanisms, away from the pub/sub matching part.
Yeah.
Okay. Yeah. All right.
Okay.
So is that okay for today?
Yeah. I just wanted to ask you a quick question again. Just to confirm. In theory, we still have the channel-based pub/sub implementation, right? Like as a added functionality.
I would say let's not worry about that for now. Okay. Because once you have a spatial pub/sub, you can add a channel-based pub/sub on top of that. Okay. But to devise something just for channel-based pub/sub, you have potentially other ways to do it. You see, let me put it this way. To support channel-based pub/sub, you have perhaps 3 mechanisms, one of which may be spatial partitioning. You see, but the other 2 are not. Okay, like you can use a tree-based partitioning, right? Or you can use like a hash-based partitioning. You see, which is actually what peer-to-peer network. There's this famous paper, CHORD. I don't know if you know about this, CHORD, CHORD. No? Okay, go Google it, CHORD. It's one of the highest cited peer-to-peer work. That was in one of the conference, CHORD, by a bunch of MIT and Harvard professors. Young professors.
Jeez, okay.
That's one of the highest cited paper in the field. Okay.
Maybe we can get them to join the team.
Yeah. I mean, that would be nice. There's actually a famous hacker, Robert Morris, who's a co-author of the paper, also a co-founder of ViaWeb with Robert. The founder of Silicon Valley's Y Combinator, and he's also a famous hacker for breaking the Cornell network with a virus in 1988. You can Google this guy, Robert Morris.
Robert Morris, okay, nice.
Yeah, so if we can join board, if we can support, that would be wonderful.
All right, okay.
He actually knows about VAST and Voronoi. I mean, VAST.
Really? Nice.
I had a quick email exchange with him like many years ago. Yeah, but he's pretty in the field. Yeah. So okay, that's a good suggestion. So let's sync tomorrow. Okay.
All right. Yes, definitely.
And actually, the core paper, I will highly recommend you to have a read of it. Okay, because then you
Okay.
will know like what is like that's the gold standard. Okay, but don't be intimidated by it because it's
Okay.
definitely doable, even if parts of it. In fact, I followed their Sudoku format in my master thesis. Okay,
Oh,
the reason
nice.
why it looks nice and concise is because that's exactly how they wrote their
How
Sudoku.
they do.
Yeah.
Nice. Okay.
Okay, so always learn from the masters. Yeah,
Yes.
you will serve
Yes.
you. Yeah.
Definitely.
Okay. All right. Okay. So that's another tip. Okay.
Yes.
All right.
Yeah.
Okay. So take care and I'll see you tomorrow. Okay.
All right. Thanks so
Okay. All
much.
right. All right. Yeah. Take care. Bye bye. Bye bye.
Yeah, bye.